Hello, hello. Hope everyone can hear me. Yeah, just drop yes if you all can hear me. Hello. Okay. So welcome class. So so we are starting a new session. By the way, this is my first video through YouTube, and we are starting a new series like 50 days. You will get 50 marks. Catchy. Okay. And so we have started the class. So I hope some more people are there to join. And by the way, sorry about the problem through the internet. And there was a small technical issue, so I couldn't do the class through my main account. I started doing through a second account, but the classes will be continued through my main account from the next class. So the next class will be from Wednesday. Excited to meet you all. So next class will be from next class will be on Wednesday and on Friday. So there are 3 days. 3 days the classes, 3 days a week. So uh, so introducing myself first. My name is Clean Jasper, and I did my O levels in 2019. And coming to the plan of these sessions, okay, this series, now we have 50 days more for your exam. 50 days more for your exam. Okay, 50 days more for your exam. So through these 50 days, we are trying to achieve a goal of 50 marks. Kind of imaginary, but it is possible. Is it possible? Yeah, it is possible. So 50 marks through 50 days. Now the plan for this is we are going to cover the grade 10 syllabus first. Okay, the grade 10 syllabus first. So covering the grade 10 syllabus is the basics. So without the basics, you can't do anything. So we will cover the grade 10 syllabus like 80%, around 70 to 80% we will be covering grade 10 syllabus. And from grade 11 syllabus, we will be covering like 50%. And I guarantee you guys, you will get 50 marks in 50 days. If you guys are in B right now, you will go for A. Guys in a C right now will go for a A. Okay, if you all work according to the plan, you will go for the A, go for a A. And people in S will surely go for a B if you all do according to the plan. And guys in S or W level, don't worry, a C is waiting for you. Okay, a C is waiting for you all, no worries. Now, now the thing is, what is my plan? Okay, every day, okay. Now 3 days we are going to have classes. Monday, Wednesday, and on Friday night 9 o'clock. 9 o'clock at 9 o'clock we are going to have the class. At 9 o'clock we are going to have the class, and every day I will be teaching paper. I mean, I target the 2022 batch the paper. I will do the theory sections which can come, like most probably can come, and then I will send you all questions. I will send you all 5 to 10 target questions every day. Every day, 5 to 10 target questions from the sections that I have teach you all. So you all won't get demotivated. It's from the section that I have teach you all. So don't worry, you all can do it. 50 days is just a small amount. Most of you all won't be doing your A levels in science or maths. So do this to a level that you all can say that I am also a science student. I got a A for science. So you can go out and say it like ගැම්මෙන් කියන්න ඕන. හරි? So now, without talking too much, okay, without talking too much, let's go into today's lesson. Now, since today is the first day, no? Today is the first day. So for the first day, I thought of doing kind of a easy lesson, but my main goal for this series is to give a good pass for a person who hasn't studied well till now. Like people who have given up, remember, you all are in the right place. You all have come to the right place at the right time. Okay? You have come to the right place at the right time. If you all have given up, if you all don't know anything, okay, from the basics, I'm going to build you all up. I'm going to take you all through this journey. We are going to get through this exam. Okay? Let's do it. Okay. So today's lesson is, do you all remember there's some guy called Newton? Based on that, we are going to do some questions, some theory parts today. In the fourth lesson, grade 10. Why suddenly fourth lesson? Why not the first lesson, second lesson, or third lesson? You all might ask. First lesson, bio. Okay, second lesson is a physics lesson, but it's uh, not that hard. It's very easy. And don't worry, I will be teaching that lesson as well. Okay. And the third lesson is a chemistry lesson. It's a little bit bigger lesson, and I will teach that as well. Integrated skills. So grade 10 syllabus, fourth lesson, I'm going to teach you all today. It's about the Newton's laws or the force. Okay, it's about Newton's laws. Very famous phenomenon. Newton's laws. Now, in your book, this is not the topic given, but I'm telling you this topic to make it easier to understand. Okay. Now, in this lesson, the main guy is Newton. Now, who is this fellow? This fellow is a scientist. Okay. Now, people know that apple guy. Apple එකක් කොළුවට වැටිලා scene එක. This is that fellow. The apple fall to his head and that gravity story. This fellow is that same fellow. Okay. Now in this lesson, we are not going to learn about much about gravity, but we are going to learn. Okay, we are going to learn about force. And what is force? Now all of you all know what is force. To push, to pull, to compress, to lift. Everything we give force. No, force is a simple thing everyone knows. To push we give force, to pull we give force. Everything like carrying, pushing something down, compressing, lifting, everything is giving force. Okay, now when you push on something, now you have something. Okay, imagine you have a very big box. It's a very big box. Okay, imagine this is, think this is a box. Okay, it doesn't look like a box, but just imagine it's a box. And now you are going to push it. Okay, now you are going to push it. To push, what are we giving? Force. Okay, you are giving some amount of force to push this box. And now to push this box, you need to give some force. And have you all guys, okay, have you all guys experienced that when you all push something, it doesn't move as soon as you give a small push like this, a small push, it won't move. You take your table now. Most of y'all might be sitting. I hope some of y'all might be sitting on a table and studying. Okay, I know most of y'all, okay, might be lying on the bed watching this like Netflix. Okay, now if you all are sitting and studying on a table, try to push it with a small force. It won't move. It won't move. You will feel someone is pushing from the other side. Huh? There is someone pushing from the other side. That opposing force, okay, that opposing force we call as friction, and friction mark will push from the other side, okay. Mr. Friction will push from the other side, okay. And now, once you increase the force little by little, okay, then at one point the table will start to move. Okay, little by little, the table will start to move. Okay, so what has happened? Friction Martha is pushing this side while you are pushing this side. Okay, you are pushing this side. When your force is more than Mr. Friction, when your force is more than Mr. Friction, the box will move this side. Ah. Now the force here is more than the force here. Here is less. Now we will see there is an unbalanced force. Now this is called as unbalanced force. Okay, this is called as unbalanced force. Now, why am I talking about unbalanced force? Why am I talking about friction? Why am I talking all of this? And I told that I am going to teach about something called Newton's laws. Where is Newton? Newton, he has died already. Okay. Now, before going into the Newton section, let's know something else about force and measurements. Okay. Let's know something else about force and measurements. Now, when you take some measurement, okay, say some measurements there, we will measure length, okay, let's say length we measure with meters, then we measure the mass by kilogram, length, meters, kilogram, force. We measure force by a Newton. A Newton only found out force, we can say no, that is wrong. Don't think Newton found out force, but there is some relationship between is Newton and force. So we measure force with Newtons. When you take measurements, okay, when you take measurements, remember you can divide measurements into two. One is scalar and one is vector. One is scalar and one is vector. Now what is scalar, what is vector? Now when you take meters, I mean length, okay, it will have 2 meters, 3 meters, yeah. Now 2 meters, 3 meters, okay, and it only has a magnitude, okay. There is a force. When we take force or something, which we say we give 5 Newton to the west, 5 Newton to the right, left, or something like that. Okay, something like that. Then it has a direction. So vector quantities will have a magnitude and a direction. Magnitude and a direction. Scalar quantities will only have the magnitude. Okay. Now, force is a vector quantity. Okay, you have to remember force is a vector quantity. Okay, because we say we push the box to the right, 5 newtons to the right, 5 newtons to the left, like that. Okay, now only we are coming into Mr. Newton's story. What? What is Mr. Newton's story? Newton's laws. He has given some laws on force. He has studied about force that much, more studies, and then he has given some laws. What are the laws? He has given 3 laws. Let's see the first law. Okay. Now, in the first law, what he is saying, okay, when you push something, when you push something, only if there is an unbalanced force. What is an unbalanced force? I told you earlier. If the force that we apply is more than the friction, there will be unbalanced force. One side force is more than the other side means it has an unbalanced force. So if there is an unbalanced force, okay, if there is no unbalanced force, an object that is in rest will remain at rest. That is true now. That is true now. Now say I have this pen, I have this marker, okay? I have this marker. And without pushing, without giving an unbalanced force, you think this marker will go somewhere? No, right? The same thing, simple. Understand. Understand, gain knowledge. Don't just by heart his theory, his laws. Many will by heart, not just by heart. You have to understand. Now, if you just keep it like this, will it just go? No, right? You have to give an unbalanced force. You have to push. Give an unbalanced force for it to go. Okay. So until there is an unbalanced force, okay, object at rest will remain at rest, and object in motion will continue to move in constant velocity. That's the law. If you don't give a force, something won't move. If you don't give a force to stop, something won't stop. It will continue to go. That is what he has told. Now, now we spoke about friction now. Let's continue some more about friction. Okay. Friction, now to reduce friction, we can do certain things. To increase friction, you can do certain things. To reduce friction, okay, you can add powder. You can add powder. How many of you all have played carom? I think everyone has. Okay, I think everyone has. And for the disc to slide, okay, the disc to slide, you have to put some powder that is decreasing the friction. So with just a slight shot, the disc will go to a far distance. And you can put oil to decrease the friction. Okay, you can put oil to reduce the friction. And next part related to Newton's first law. Okay, related to Newton's first law. What did he say? Until an unbalanced force is applied on an object, object at rest will remain at rest, object moving will continue to move in constant velocity. Now, you are standing in a bus. You are standing in a bus. Okay, like this on the bus. Okay, now your body is fully stationary. It's standing in the same place. It's stationary. When the bus is at rest, it's at rest. Then the body is stationary. When the bus starts to move in front, okay, the unbalanced force is applied here to your lower body. Okay, upper body no force is applied. Lower body only the force is applied. That's why when the bus is going front and you haven't hold on to something, you're going to fall back and hit your head. Okay, because the force is generated like this. Here it is stationary. Here it is stationary. So here it will stay stationary. It will go front and you will fall and hit your head and get into big problems. Okay. Now, Newton's first law is over. It's a great thing, right? Newton's first law is over. Now we are going to study about Newton's second law. Okay? It's Newton's second law. This is the second law. It's Newton's second law. What is the second law? Now I think almost all of y'all, okay, almost all of y'all have experienced this thing. Okay, what is it? Think there is a big, there's a big box or something which is very heavy, okay, very heavy, okay. The amount of force needed to the amount of force needed to push that box is very high. The amount of force needed to push that box is very high. I think all of you all have experienced that at some point. Okay. And the other thing is, have you all seen when you give more force? Okay, the acceleration. That means the speed will increase fast. Say you're pushing a box with a very high force, like okay, it's gonna go very fast. It's gonna accelerate a very high speed. Okay, so what Newton told was, yeah, there is a small word called directly proportional, indirectly proportional. Don't worry at all. Now, what he told was force acceleration is directly proportional to force. What is he telling? මේම කිව්වොත් මොකුත් තේරෙන්නේ නැහැ. Yeah. So what is he telling? When you give more force, more acceleration. More force, more acceleration. Okay? That's what he is telling here. And the next thing what he is telling is, when there is more mass, the acceleration will be less. The acceleration will be less. That's what he is telling. Okay, what is he telling? More force, more acceleration, more mass, less acceleration. That's what he is telling. So he has told acceleration, okay, acceleration is directly proportional to the force, okay, to the unbalanced force, and it is inversely proportional to its mass. It is inversely proportional to its mass. And through this second law, only all the problems starts when it comes to physics. From here only we derive an equation called F is equal to ma. You might have heard this equation many times, so many times. Okay, you might have heard this equation so many times. F is equal to ma. Now, what I told, what is he telling from this? And you guys have experienced it. Okay. Now we'll go to the third one. We'll go to the third one. What is the third law? Let's go to the third law. What's the third law? He says every action, okay, every action has an equal and opposite reaction. So true. What you do for others, only you will get no simple logic. Give and take policy. What you do for others, you will get. Simple. Same thing. Every action has an equal and opposite reaction. And you go and fight with someone on some day, that person will fight with you on another day. Okay? Every action has an equal and opposite reaction. For this, the example given in your book, the example given in your book is a balloon. It's a balloon. Okay? Example given in the book is a balloon. You blow a balloon, okay? You blow a balloon, hold it upside down, and you release. You blow, keep it, and you raise the amount, it's gonna go up in a very high speed. Okay, it's gonna go up in a very high speed. Now, what is happening here? What is happening? The air inside is pushing the air outside. I mean, the air particles inside the balloon is pushing the air particles outside the balloon. It's pushing down, it's pushing outside. And the air particles outside will push the balloon up. Okay? Will push the balloon up. So every action has an equal and opposite reaction. You put the action, you give a force like this, you will get a force like this. Now just push the wall and see. You will be pushed with the same force that you push the wall. Same force you push the wall, you will get back. That is it. That's what he is telling. And there are several examples given in your book. Okay, given in your book, there are several examples. One of it is there are two kids sitting on a wooden, I don't know what to call it, like a skating board, and they push on each other, and both of them will be pushed to a same amount of distance, same amount of force, equal and opposite reaction. Everything has an equal and opposite reaction. Okay, that's the third law. I hope you guys understood. And before going to the next topic, I just want to tell you that in this class, okay, in this class, I'm not going to go like the old traditional method of going with the same thing given in the book, like the same order given in the book. I'll be mixing up things from different lessons. I'll take certain things, put it into this lesson. I'll take certain things from another lesson and put it over here. So you will get a better understanding when you have links. In science, all the subjects, all the physics subjects especially, are interconnected, but we are not taught in the way that it is connected. Now, those connections, once you understand the connection between these, science is going to be the easiest subject for you all. Okay, science is going to be the easiest subject. So, what I am trying to do in this 50 days, I am trying to give you all the blueprint of studying science in an interesting way. I am trying to give you all the blueprint of how to study science. Okay, so now don't worry, some things that I tell are not in the book in this lesson, but it is there in the other lessons which I tell you. It is there in the other lessons which I tell you. Okay. maybe now the friction part. The friction part was not in this lesson. The friction is the fifth lesson. This is the fourth lesson, but I taught you all the fifth lesson and the fourth lesson kind of combined, but it's not all about the fifth lesson. I will do the fifth lesson separately on another day. Okay, so let's move on to the next part. Now there is something called momentum. But before the word momentum, I want to tell you all something. Okay. Now imagine your friend is throwing a pen at you. If your friend is throwing a pen or is throwing a ball at you, he's taking a ball, throwing at you. Easy to catch. Okay, easy to catch. You can stop that ball easily, quickly can catch. And now imagine your friend is throwing some big object, okay, not that heavy, he's just throwing. You can hit and stop it. Say it's a football, it's coming with a very high force, okay, very high speed or something, you can stop it with your hand. Now imagine there is a train coming and you're going and standing there like Rajinikanth, keeping a hand. Okay, like in movies, you're going and keeping the hand trying to stop the train. But the big train, you're trying to stop the entire train with one hand. Like this. Is it possible? No. Is it possible to stop the train with one hand? No, right? It's not possible at all. Okay. Now, momentum, momentum means momentum means how hard is it to stop something which is moving towards you? How hard is it to stop something which is moving towards you? That is only momentum. Okay, how hard, how difficult is it to stop something which is moving towards you? Like a ball is coming towards you, okay, you can catch it, you can stop it easily. Say a big train is coming towards you, okay, hard to stop. Yeah, it's very hard to stop. Now, say there is a 500 grams ball. There's a 500 grams ball. I think everyone knows the weight of 500 grams. Okay, I think everyone has gone to the shop to buy sugar. Unfortunately, now everything is too expensive. But what to do? We have to buy these things. So 500 grams of something your friend is taking and throwing at you. Easy to catch, no? Easy to stop it. You can quickly stop it. Okay. Now imagine there is some big giant. Okay, big giant is taking 500 kilos and throwing at you. Okay, he's taking 500 kilos, throwing at you. Is it possible for you to? Is it easy for you to stop it? Huh? Is it easy for you to stop it? No, very hard. So difficulty increase. The difficulty to stop 500 kilograms is more than to stop 500 grams. Okay, 500 grams. So now, and the next thing, how the difficulty is depending. Okay, now say your friend is throwing, say 500-gram ball or something. Same 500-gram ball, he is throwing at a certain speed. He is throwing at a certain speed, you can catch. Now he is throwing with a very high speed, like Lasit Malinga. Okay, he's throwing that ball at a very high speed. It's very hard to catch. The difficulty increases. Okay, so there are two factors on which the difficulty to stop something depends on. There are two factors on which the difficulty to stop something depends on. One is the mass. That's why when it's 500 kilos, it is impossible to stop. When it's 500 grams, it is possible to stop. Okay. And the next thing is the velocity. Velocity means the speed. Okay. The speed. How fast is it coming? When the ball is coming too fast, it is hard to stop. It is very hard to stop when it's coming very fast. So velocity and mass are the two things which will depend, which will affect the momentum. So that's a formula. Now for everything there's a formula, right? There's a formula. Where momentum term is equal to what are the two things that will affect mass into velocity. So remember, mass into velocity is momentum. Mass into velocity is momentum. Mass into velocity is momentum. Okay, this one is called. Then what is mass into acceleration? Similar, right? Mass into acceleration is force. Force is mass into acceleration. Momentum is mass into velocity. Okay, there's a small difference. Only one factor is different from each other. Easy. Okay, now, now the next thing is there's something called mass, there's something called weight. There's a small difference. Now, whenever we say we are going to see the weight of us, okay, we are going to see the weight of us. We'll go to some place, or maybe most of your houses will have a scale. You'll go and stand on it, and you'll see the kilogram amount. You think this is your weight. Say you are 100 kilos. Okay, you're 100 kilos. You'll say my weight is 100 kilos, but actually speaking, scientifically, this is wrong. Okay, this is wrong. 100 kilos is wrong. Okay, this is not your weight. Let me explain it. Okay, there is someone called mass. There is someone called weight. Okay, now what is mass? Okay, what is mass? Now, mass means when you take some substance, okay, when you take some amount of substance, it is made up of atoms. No? When you take some substance, it is made up of atoms. Okay, when you take mass, or when you take some substance, okay, when you take this board, when you take this board, this whiteboard is made up of atoms, molecules, or something. Huh? So the amount of atoms or molecules or something that is making this board is known as mass. I mean, now let's say there is a cup of water. Okay, this is a cup. There is water. Till this level, there are water particles. I mean H2O. That is the molecule, water molecule. The number, a measurement of the amount of H2O present in water is called mass. Okay? The amount of H2O present in water is called mass. Okay? Then what is weight? Then what is weight? And before that, mass is measured in kilograms. Mass is measured in kilograms. Then what is weight? Weight is the force this mass will exert on the floor. Or if we keep this mass on some surface, the force that mass will exert on the floor is called weight. Now see, I'm 65, 70 kilos. Okay, say I'm 70 kilos. I'm trying to sit on your head, sit on your head or stand on your hand. Now I have a certain amount of mass. No? Me standing on you will give a force on your hand or on your shoulders. Okay, me standing on you will give some force on you or on your shoulders or on your hand. Huh? That force is called the weight. The force exerted by the object on a surface. The force exerted. Then force is the SI unit. I mean the unit of force is what? Newton. The unit of force is Newton. So the weight should be calculated in newtons because weight is a force. Weight is a force. Now, how to find the weight? Okay, how to find the weight? Let's see. Okay, force is equal to mass into acceleration. Force is equal to mass into acceleration. Now if we know the mass, if we know the kilogram amount, if we know the mass, okay, if we know the mass, we can substitute that mass amount over here, okay. And what is this acceleration? Where are we moving? If we move only, we have an acceleration. Where are we moving? And that is a misconcept. Okay, misconcept or thing that you haven't understood or something that you don't know. You don't need to move to have an acceleration. You know there's something called gravity now. Mr. Newton found it. Mr. Newton found it. There is gravity now. Gravity is an acceleration. Okay, gravity is an acceleration. So gravity, remember, gravity is 10 meters per second square. It is 9.8, but you can write it as 10. In your exam, they won't ask to calculate using 9.8. Okay, we don't use calculators. So 10 meters per second. Okay, so for acceleration, you can put 10 meters per second. Okay, 10 meters per second, then you can get the amount of weight. So the amount of weight equals mass into gravity. Weight equals mass into gravity. Okay. So now you know what is mass. Now you know what is weight. Okay. So like that, this lesson about Newton's law has come to an end. Easy, right? It's very easy. It's just understanding the small points. Now, just studying this theory of a physics lesson is not just enough because physics is practice. You have to practice. Without practicing, you can't do physics. Okay, you have to do many questions as possible, and I'll be sending you all questions every day. Every day, 5 to 10 questions I'll be sending you all. So you all, if you all want to get a better results, okay, if you all do this, you can get a better result. I will send you all 5 to 10 target questions. From it's just beginning now. So we might answer like 5, 8 or something. But once we grow like 2, 3 weeks into this, we can do 10 questions a day. Okay, 10 questions a day. So like that, you will get the practice to answer a question, and you will lose the fear of writing an exam, answering a question. Once you see a question, you will lose that. Once you see a question, now you will have some sort of a fear. Can I answer? Can I do this? Can I do that? But you can do it once you get practice. Okay, easy. Just try doing the questions that I send you all, and send me the answer. The group admin send me the answers personally, or yeah, personally. Send me the answers personally. And also, if you all have some lesson which you all think it's very hard, okay, a lesson that you all think it's very, 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 very hard for you all, drop me a message, okay, tell me which lesson you want to study, okay, put it in the group, or send me a personal message, okay, which lesson is very hard for you all, so we can do that lesson first, okay, to make your guys a little bit confident, okay. So I hope you all guys understood this theory part, okay, and answer many questions as possible, do many questions as possible, do past papers, and follow the plan. And I guarantee you guys to get a better results than what you are now, okay. And since it's the first day, I chose to do a little bit a smaller lesson, and start it in a fun manner. So once we go into few more days, like when we go to another 2 days, 3 days next week, maybe I'll extend the class to 1.5 hours. Now it's only 1 hour, 1.5 hours. It's possible, okay? Depending on the amount of work that we have to do. And every day the question should be answered and sent if you all want to get a better results. Okay? And thank you for thank you for joining to today's session. And thank you. That's it. And the next session will be through the main account, the main channel, the main YouTube channel, which is GLN Education, the channel that you guys have subscribed. So join through that, and I'll update you all guys for like which lesson we have to do. So thank you for joining today's session. Have a nice day. No, I mean, good night. Thank you for joining for today's session. Thank you.